If you were to take 100 people born in the 1930s and 100 people born in the 1970s, line them up side by side, and measure their heads, you'd find something weird. The 1970s group's heads would be, on average, about 6.6% larger. That's roughly the size of a large egg worth of extra brain matter in just 40 years, which, okay, maybe people born in the 1970s are just taller, better nutrition, right? Except when researchers control for height, for body size, for everything else, the difference doesn't go away. In 2024, a team at UC Davis analyzed brain scans and autopsy data from over 3,000 Americans born between the 1930s and 1970s. One thing was clear: brains were getting bigger. And it hasn't been happening over thousands of years. We're not talking about evolution. We're talking about 2 generations, your great-grandparents versus your grandparents. So good news, right? Bigger brains, we must be getting smarter. Except there's no evidence of that. IQ scores have been pretty flat across that period, and brain size doesn't really correlate with intelligence anyway. Einstein's brain was smaller than average. So if we're not getting smarter, then why are our brains getting bigger? And maybe more importantly, should we be concerned? Because as we'll see, the answer might tell us something uncomfortable about what we've been doing to ourselves for the past century. Here's what we know. Around 2 million years ago, our ancestors had brains about 1/3 the size of ours. That is 500 cubic centimeters, and roughly the size of a grapefruit. But as early humans started using tools, hunting in groups, and developing language, that volume exploded. By 200,000 years ago, anatomically modern humans had brains averaging 1,500 cubic centimeters. But the brain is an incredibly expensive organ. It's only 2% of your body weight, but it uses about 20% of your energy. So, evolution doesn't just make brains bigger for no reason. There has to be a significant survival advantage. And for most of human prehistory, there was. Bigger brains meant better problem solving, more complex social structures, and a superior ability to adapt to new environments. But about 20,000 years ago, right around when humans started settling into agricultural communities, brain size started decreasing. By some estimates, we lost about 10% of our brain volume over the next 15,000 years. Scientists aren't entirely sure why. Some think it's because agriculture made food more reliable, reducing the cognitive demands of hunting. Others believe it's because living in larger, more complex societies meant individuals could specialize. You didn't need to know everything yourself. One controversial theory suggests that as we domesticated animals, we were also domesticating ourselves. Just like how dogs have smaller brains than wolves, humans may have selected for less aggressive, more cooperative individuals, and that came with smaller brains. It's not that we became dumber, our brains just became more efficient, more networked. That was the pattern for thousands of years, until recently. In 2024, researchers at UC Davis published a study that analyzed brain scans and autopsy data from over 3,000 Americans born between the 1930s and 1970s. What they found was striking. People born in the 1970s had brain volumes about 6.6% larger than people born in the 1930s. But even more striking was that the growth wasn't uniform across the entire brain. The researchers documented increases in white matter volume, in cortical surface area, and in the hippocampus. These are all areas associated with memory, learning, and cognitive function. But the growth pattern doesn't match what we typically see in evolution. That's because evolution works over thousands of generations. This is happening in 2 or 3 generations, which means it isn't genetic evolution. It's something environmental. So What changed in the environment? The obvious answer is nutrition. People born in the 1970s had access to better food than people born in the 1930s. They had more protein, more vitamins, more calories during critical developmental years. A 2019 study in The Lancet found that malnutrition, especially in early childhood, has devastating effects on brain development. Improved nutrition could absolutely account for some of this growth. After all, height has been increasing for similar reasons. But nutrition alone doesn't explain everything. The study population came from Framingham, Massachusetts, a middle-class town. These weren't people experiencing severe malnutrition in the 1930s, yet their brains still grew significantly smaller than people born just a few decades later. And even after controlling for height and body size, the brain growth persisted, which suggests something more than just basic nutrition is at play. Education has expanded dramatically. People born in the 1970s spent more years in school than those born in the 1930s. Some research suggests that education can actually change brain structure, increasing gray matter density in certain regions. There's also reduced exposure to diseases. Childhood infections can impair brain development. Vaccines and antibiotics have dramatically reduced these impacts. But there's another theory, one that's a lot less comfortable. It's the idea that we've spent the last century building a world our brains were never meant to handle. Someone born in 1930 lived in a world where information moved slowly. A letter took days. News came once a day in a newspaper. You didn't know what was happening beyond your neighbor's farm stories. But by the 1970s, things had changed. Now people grew up learning to navigate subway systems, decode television, process advertising, and manage relationships across cities. Computers were already common by the time they hit adulthood, tracking global news, coordinating schedules across time zones. The amount of information they had to process every day was orders of magnitude higher, which corresponds to what the UC Davis study found. The biggest increases in brain mass were concentrated in white matter, cortical surface area, and the hippocampus, the exact regions involved in processing complex information and spatial navigation, which raises the possibility that brains grew because they needed to, because the environment demanded it. But there's a cost. Brains are expensive. They consume about 20% of your body's energy, and they require constant maintenance, nutrients, oxygen, blood flow. You can't just scale that up indefinitely. Some researchers think the extra volume might help. More brain tissue could mean more reserve capacity before age-related diseases, like dementia, show symptoms. And then there's the question nobody can answer yet. If brains grew nearly 7% from the 1930s to the 1970s, what's happening to kids born in the 2000s, the 2020s? Kids who've never known a world without the internet, who navigate dozens of apps daily, who process more information before lunch than someone in 1930 processed in a month. We don't have the data yet. The studies haven't been done. But if the pattern holds, their brains should be even larger. We've built a world that runs faster every decade. More information, more complexity, more decisions. And human brains have just been responding in real time.